Okay, in this video, we're going to be talking about polynomial functions and end behavior. First off, again, a polynomial function is a function of the form f of x or y equals, and you see a(n) x of n, a of n minus 1, x of n minus 1, to where a sub n minus 1, a sub n minus 2, these a numbers out here are called coefficients. These are real numbers, 1, 3, 1/2, 4. And n is going to be in positive integers, x to the third power, x to the second power, x to the first power. Again, the coefficients, a sub n minus 1, a sub 1, a sub 0, all of these a numbers are real numbers. A sub n is not 0. This right here, this first coefficient here is not 0, or the first number out front. Again, n will be all positive integers, no negative exponents. A sub n, this first number out here, and this is going to be important to our lesson, is called the leading coefficient. Again, a coefficient is a number that's being multiplied by your variables. In these examples here, we're going to classify each polynomial function by the degree. And the reason we're doing this, in order to find the degree, you're looking for the highest power variable. Like in this first one, the highest power is this x to the 0 power. There's no x's there, so the degree of this would be 0. It's a constant. The number on the highest power, the coefficient of the highest power, again, is called the leading coefficient. So in this case, it's going to be a 4. The highest power here is a 1, so it's a first degree polynomial. It's linear. The coefficient on that variable is a -5. Here, the highest power is a 2. Because of this, and the coefficient in front of it is a 12. Here the highest power is a 3, and the coefficient, the number in front of it, is a -1. Here your highest power is a 4, the coefficient is -3, and here the highest power is a 5. It's a 5th degree polynomial, and the coefficient is a 9. So now how are we going to use that? It's going to tell us that highest power coefficient is going to tell us the general shape of these functions. The polynomial parent functions. We're going to identify each parent function, then sketch the graph using your graphing calculator. And instead of doing that, I'll just show you what each of them are going to look like. Your first one, your constant function, is going to be f of x or y is equal to some constant c. And that constant can be a 1, a 2, a 3, or 4. It doesn't matter. This function is always a horizontal line. Y equals 3, y equals 4, y equals 5. These are all horizontal lines. Next one, your linear function. The parent function of all of your linear functions is y is equal to x. Try again. And that's going to have a slope of 1. And it's going to have a y-intercept of 0, and it's going to be a linear function that looks like this. Your parent function of all the quadratics is y or f of x is equal to x to the second power, and you can plot some points that'd be 0, 0, 1, 1, -1, 1, 2, 4, -2, 4. It's parabolic, and it looks something like this. Your parent function for all the cubics are y equals x to the third power, and looks something to this effect. Comes down at 0, 0, and then curls around and comes down this way. Your quartic parent function, which would be f of x, is equal to x to the fourth power. Looks a lot like x to the second, except for it's going to flatten out more, right around that 0, 0, and it's going to look something like that. Your quintic, f of x is equal to x to the fifth power. Looks a lot like the cubic, except for it flattens out and grows a whole lot faster after that. So it's kind of flattens out around the origin, and then it grows really fast after that because you're raising things to the fifth power. Okay, the end behaviors now. We're going to use these functions to actually describe what's called end behavior. It says, using your graphing calculator, determine the end behavior of the following functions. Now let's explain what this means. End behavior as x goes to infinity. What that means is, here's your x-axis. As x goes to infinity simply means as you move to the right on your graph. What does y do? Does y go up or does y go down? And then as x goes to negative infinity, well, here's negative infinity on your graph. So what that means is, as you travel to the left, as you go this way on your graph? Does your graph go up or does your graph go down? So using a graphing calculator, we'll use Desmos. We're going to graph each of these and we're going to describe. We're going to try to figure out what does my graph do as I travel to the right or as I travel to the left. Okay, our first function is 4x to the fourth plus 6x to the third minus x, and here is a look of it. As we travel to the right on our graph, look at what your graph's doing. As you move to the right, your x values go up. Let me see if I can get my... There we go. As we move to the right, my x values go up forever. And as we move to the left on our graph, notice the x value, or excuse me, the y values is what I meant. As your x values increase, as you go to the right, your y values go up. As you move to the left, your y values go up. So here's how you're going to write that. As x goes to the right, that's what this means. Your y values go up, positive infinity. As you go to the left, your y values go up. Positive infinity is up forever, negative infinity is down forever. Number 2, negative x squared plus x. Okay, here's that graph. Notice as you go to the right on your graph goes downhill. As you go to the left, your graph goes downhill. So the way you write that. As you go to the right on your graph, as x approaches positive infinity, your y value goes down. As you go to the left on your graph, your y value also goes down to negative infinity. Number 3. F of x equals 2x to the third. Here's that graph. Notice as you go to the right on your graph is going uphill. As you go to the left on your graph is going downhill. So therefore, as you go to the right, your graph goes up to positive infinity. As you go to the left, your graph goes down to negative infinity. And it's as simple as that. It's just, is your graph going up or is it going down? Number 4, negative x to the third. Here's a picture of the negative x to the third. As you go to the right, your graph goes down. As you go to the left, your graph goes up. So as you go to the right, your graph goes down. As you go to the left, your graph goes up to positive infinity. Number 5, negative 2x squared plus 4x minus 7. We should know this one because that's quadratic, the negative out front, but let's go ahead and look at the graph anyway. Okay, here's the graph. As you go to the right, you're going downhill. As you go to the left, you're going downhill. So therefore, as x goes to the right, positive infinity, y goes down. As you go to the left, y also goes down. And number 6, the last one, 1/2 x to the third plus 7. And here's what it looks like. As you go to the right, your graph goes up. As you go to the left, your graph goes down. So therefore, as you go to the right, your graph goes up. As you go to the left, your graph goes down. Now we can take those 6 problems and we can start investigating. Okay, what happens when we have even degrees? Okay, 2 different things happen, and you can look at for even degrees, and we're talking about our leading coefficient. This one is even, this one's even, and this one's even. Okay, look at the similarities. When the number out front is positive versus when your leading coefficient is negative, as it is with these two, the same thing happens. It doesn't matter if it's x squared, x to the fourth, x to the sixth. When it's even, the same thing happens. And here's what happens. When it's an even degree, if it has positive leading coefficients, as you travel to the right, your graph will always go up. As you travel to the left, your graph will always go up. And that's what they're wanting you to do. It says draw sketches to help remember the end behavior patterns. Okay, when the leading coefficient is negative, it's going to take that graph and it's going to flip it over. As you go to the left or as you go to the right, your graph's going to go down. Okay, now all depending on if it's x squared, x to the fourth, x to the sixth, it does different things in the middle of those 2 lines, but at the end, that's what happens. If it's an odd degree, and you can look at the other 3 problems there to figure out what happens with odd degrees. When the leading coefficient is positive, as it is here or here, you see the same answers. Or if the leading coefficient is negative, as it is here, you have the same thing flipped. So here's what happens with odd degrees. When your leading coefficient or your highest power term is an odd number, to the right, it's going to go uphill. To the left, it's going to go downhill. Whenever you put a negative leading coefficient, it flips it over. To the left, it'll go uphill, and to the right, it'll go downhill. So that's what's going to happen with all of these. Like here, let's determine Determine the sign of the leading coefficient. Well, look what it does to the outside. It goes down and it goes down. So that's this scenario. So determine the sign of the leading coefficient and whether the function is an even or an odd degree. So therefore, this would be an even with a negative. I'm going to put LC, leading coefficient. The second one, look, it goes down to the left, up to the right. Down to the left and up to the right would be this case. They go opposite directions, so we know it's an odd with a, that would be a positive leading coefficient. So positive leading coefficient.